Imagine buying electricity just like mobile balance. In this project, I have developed a smart prepaid energy meter using an ESP8266 NodeMCU, PZEM-004T energy monitoring sensor, and a relay module. The system works on a prepaid voucher mechanism. When the user enters a valid recharge voucher through the web interface, the corresponding energy units are added to the meter. As soon as the voucher is accepted, the relay turns on and electricity is supplied to the connected load. The PZEM-004T continuously monitors and displays real-time electrical parameters, including voltage, current, power, energy, frequency, and power factor. The remaining prepaid units are deducted automatically based on the energy consumed, and the live consumption can be monitored through the ESP8266 web dashboard. Once all the purchased units are consumed, the system automatically disconnects the load by turning off the relay, preventing any further electricity usage until another validated voucher is entered. This project demonstrates how IoT and embedded system can be used to implement a low-cost smart prepaid electricity solution for homes, hostels, rental properties, and educational purposes. It provides real-time monitoring, automatic billing based on energy consumption, and intelligent power control, making it an effective prototype of modern prepaid energy meter. So let's get started. We will require the following components for this project: ESP8266, PZEM-04T sensor, 16x2 I2C LCD, relay module, breadboard, jumper wires, and light bulb. The PZEM-004T is a digital AC energy monitoring sensor used to measure and monitor electrical parameters in real time. It can accurately measure voltage, current, active power, energy consumption, frequency, and power factor of AC loads. The sensor communicates with microcontrollers such as the ESP8266, ESP32, and Arduino through a TTL serial UART interface, making it easy to integrate into the IoT-based energy monitoring project. The PZEM-004T provides high measurement accuracy and allows continuous monitoring of electricity usage without complex calculation. It is widely used in smart energy meters, home automation system, industrial power monitoring, renewable energy project, and prepaid electricity meter application. In this project, the PZEM-004T continuously measures the electrical parameter of the connected load and sends the data to the ESP8266, which displays the reading on a live web interface and deducts prepaid units based on the energy consumed. Connect the VCC pin of the PZEM-004T sensor with 5V of the ESP8266, ground pin with ground. Connect the TX pin with D4 and RX pin with D5. The sensor is connected directly to the 220V AC mains, which allow it to measure supply voltage of the connected load. At the other end of the module, a current transformer is provided. The live wire supplying the load is passed through the CT sensor, enabling it to measure the current flowing through the load without requiring a direct electrical connection to the conductor. Using the measured voltage and current, The PZEM calculates the real-time power, accumulated energy consumption, frequency and power factor. A 5-volt single-channel relay module is used to control the AC load in the prepaid energy meter system. The VCC pin of the relay module is connected to the 5-volt supply, while the ground pin is connected to the common ground. The signal in pin of the relay module is connected to D7. The AC bulb is connected to the relay contacts by wiring one terminal of the load to the common and the other switching path through the normally open terminal. Connect the VCC pin of the 16x2 I2C LCD with 5V, ground pin with ground. Connect the SDA pin with D2 and SCL pin with D1. This project operates on 220-volt AC main supply, which can cause severe electricity shock if handled improperly. Always follow appropriate electrical safety procedures. Before uploading the program to the ESP8266, install the required libraries in the Arduino IDE. Install the PZEM-004T library to enable communication between the ESP8266 and the PZEM-004T monitoring sensor. This library is responsible for reading the real-time electrical parameters, including voltage, current, power, energy, frequency, and power factor. Install the liquid crystal I2C library to interface the 16x2 I2C LCD with the ESP8266. This library is used to display important information such as Wi-Fi status, IP address, prepaid units, voucher status, and system messages during operation. The prepaid energy meter allows the unit price to be configured in the program according to the local electricity tariff. You can modify the unit price variable in the source code to match the desired cost per unit. For demonstration and testing purposes, the project uses a demultiplier value of 1500. This causes the prepaid units to decrease much faster, making it easy to verify operation of the voucher system, energy deduction, and automatic relay cutoff within a short period. For actual deployment, the demultiplier value should be set to 1, so that energy units are deducted at the correct rate based on the measured power consumption. The system stores 10 predefined recharge vouchers, each associated with a different recharge value. Once these valid voucher codes are accepted by the ESP8266, when a valid voucher is entered through the web interface, the corresponding prepaid units are added to the user balance and the relay is activated if sufficient units are available. If any voucher code other than the predefined one is entered, the system displays an invalid voucher message and rejects the recharge request without adding any units. This predefined voucher mechanism ensures that only authorized recharge codes can be used, improving the reliability and security of the prepaid energy metering system. After powering on the Smart Prepaid Energy Meter, the 16x2 I2C LCD displays the message connecting Wi-Fi, while the ESP8266 attempts to connect to the configured wireless network. Once the connection is successfully established, the LCD displays the assigned IP address, which is used to access the web-based monitoring interface. Since no recharge voucher has been entered initially, the prepaid balance is 0 and the system displays load disconnected. In this state, the relay remains off, preventing power from being supplied to the connected load. Next, the displayed IP address is entered into a web browser. The web interface opens successfully and displays all real-time electrical parameters measured by the PZEM-004T sensor, including voltage, current, power, energy, frequency, and power factor. Because the load is disconnected, the current and power reading remains 0, indicating that no energy is being consumed. To recharge the meter, one of the valid voucher code defined in the program is copied. And entered into the voucher field on the web page. After submitting the voucher, the system verifies the code, add the corresponding prepaid unit to the balance and energize the relay. The connected load turns on immediately, and the prepaid energy consumption process begins. At the same time, the web interface and the 16x2 LCD display the updated balance and continuously refresh the measured electrical parameters. As the connected load consumes electricity, the remaining prepaid unit decreases automatically based on the measured energy consumption. When the available balance reaches zero, the ESP8266 deactivates the relay, disconnecting the load automatically. The web interface and LCD both indicate that the balance has been exhausted and the load has been disconnected. To verify the voucher security feature, the same voucher code is entered again after it has already been used. The system correctly rejects the request and displays the message, "Voucher already used," confirming that each recharge voucher can only be redeemed once. Finally, another unused valid voucher is copied from the predefined voucher list. And entered into the web interface. The system accepts the new voucher, restores the prepaid balance, and reconnects the load by turning the relay on. Energy consumption resumes normally, and all electrical parameters continue to update in real time. When the remaining balance becomes low, the system also displays a low balance warning message, informing the user that another recharge will soon be required. The Smart Prepaid Energy Meter can also be monitored and controlled using a mobile phone connected to the same Wi-Fi network. By entering the ESP8266 IP address into the mobile web browser, the user can access the live monitoring dashboard without installing any additional application. Initially, since the system has been recharged, the relay remains off and the load is disconnected. To test the recharge process, an incorrect voucher code is entered first. The system immediately rejects the request and displays an invalid voucher message, confirming that only predefined voucher codes are accepted. Next, a valid voucher code is entered. The system successfully verifies the voucher, adds the corresponding prepaid unit to the balance, and activates the relay. The connected load turns on and the web interface begins displaying live energy consumption. The mobile dashboard also shows the remaining prepaid units, remaining balance, and all real-time electrical parameters, allowing the user to monitor electricity usage from anywhere within the local Wi-Fi network. The web interface also provides a manual relay control. By pressing the relay off button, the relay is deactivated and the load is disconnected immediately. Pressing the relay on button energizes the relay again, reconnecting the load and allowing normal energy consumption to continue, provided that sufficient prepaid units are available. The Smart Prepaid Energy Meter was successfully developed using the ESP8266 NodeMCU, PZEM-004 Energy Monitoring Sensor, 16x2 I2C LCD, and a relay module. This system provides real-time energy monitoring, prepaid voucher recharging, automatic unit detection, and automatic load disconnection when the balance reaches 0. If you found this tutorial helpful, please like the video, share it with others, and subscribe to the channel for more Arduino, ESP8266, ESP32 and IoT project tutorials. Thanks for watching, and I will see you in the next tutorial.